Hello and welcome to another tutorial. So this is the second part in the two-part series taking a look at adding in more animation support to the AI behaviors. So in the previous video, we set up our animation interface, a lot of the core logic that we needed there. We also added in support to our interactions for having animations requested there. What we're going to be looking at this time is we're going to be adding in support into our behavior trees in particular for animations, so being able to play a particular animation. So with this, I am continuing on from the previous video. So there in the description below, you'll find 3 links. One is a link to the code as it is at this point in time. So if you're wanting to follow along as I'm working on this, that's the version to download. If you're wanting to go to the version just at the end of this, that's the second link in the description. And finally, if you're wanting to more bring this into an existing project, then I have a link to the completed AI package there. Now that, depending upon when you're sort of watching this video, that package may have had further additions because it is one that I update every so often. So there may be further additions there to that. But those are all available there for you. So let's dive on in. So this is one that I don't necessarily need to set this up in all of these. I think I'll stick with the Sims one, but what I'll end up doing is I'll turn off the interactables so that they essentially have to wander around and do other things. So what my focus is I want to set up so I can have an action that can perform animation requests. So what I'm going to start off with is our initial point is I'm going to head to our behavior tree where I've got our different bits of logic. There we go, behavior trees. So I want to set up a new action node here. So this is going to be an action node that sends an animation request. So I'm going to have BT action send anim request. I should call that send animation request. So that can all reload. Now that's going to be based off of our action node base. And we'll clear everything out there because there's going to be a bunch of things that we need to then populate into this. So let's tell it to populate all of those standard things. So our debug display name, that becomes a get, a protected set. That, and we'll just actually set that right now to send animation request. So that's good. So a couple of options that we want to actually have with this. So be useful to be able to wait for the animation to complete. So wait for completion. And by default, we won't, but I want to have that as an option. We're going to keep track of the animation request to send. This is our animation or request data. Call that request data. And then what I'm going to also keep track of is our request ID. So the current request ID, we default that to -1, and we keep track of if it is complete, which by default it's obviously not going to be. So that's a couple of the key bits of information that need to obviously be populated into this. So similar to with our other actions, we do need a constructor for this. So we have a constructor. So that initially what we want to have taken in is a request Now, the other thing there that's going to be useful is that wait for completion. Which will default that to true. And then we allow also overriding of the display name, which I'm going to set to null. Then we have a fairly consistent set of logic of what we do with these. At some point, I should be able to clean that up so it doesn't need that repetition for all of them. But for now, we'll bring that over, store our request data, and store the wait for completion. Those are the only two bits that we actually need to store with it. Then we'll get to the tick. What I want to set up first is our protected override and our on enter, because when we enter, that's when we actually want to issue the animation. So I need to be able to access the animation interface. And what I normally would do for that is check, okay, well, owning tree, but I don't have the animation interface on it yet. So that's actually sort of the first thing that I want to get set up is if I go to my behavior tree, then I want to set up here, and we'll put it after the performer interface. Technically, I could get it from the performer, but I think that embeds it too much within the actual performer there. I think it is better to actually have it be accessible at this point. That means when we initialize, that needs to be passed in like that. So that's going to make a couple of things grumpy, which is okay, because what we can do is we can go and fix those then. So those will get our eye animation interface like that. So that goes into our BT instance, and we should find that it doesn't have the actual initialize needs to be updated as well. So that gets updated. We populate that here as well. Now that will likely mean other areas get grumpy, which is okay, because our brain base, I believe we already have our animation interface being stored, which we do. Because if we check, we already have the location for that happening, so that's good. There might be other ones that get grumpy at us, which there is. So this is for our GOAP action, and that is initializing a behavior tree, so that needs an animation interface, but we don't have that accessible at this stage. So if we go to our GOAP action base, then we can see we do normally have those provided there. I don't think those are, no, those aren't on the actual interface for it. So have a protected eye animation interface like that. We need to do our service locator logic. And we do our async, searching for our animation interface, and like that. Autocomplete is doing quite a solid job on this one, which it honestly should, because you implemented this that many times that it really should actually work pretty reliably. So that's good. Our GOAP action base has that there. That means our GOAP action behavior tree can provide our animation interface. So we'll see if anything else is still grumpy. So nothing else is still grumpy. That's good. So that's promising. That means we can now start actually implementing the logic for the sending of the animation request. So we can close all of these because we've gone and updated those. Don't need those. And I'm just going to close all of those other tabs. So when we enter this, I need to first check, do we actually have an animation interface? So if our owning tree and our animation interface is invalid, then our last status, we would say that we failed, and I return immediately. If I'm waiting for completion, then what I want to do is yes, I'm waiting for completion, then is complete is set to false. Otherwise, what I would do is default it to true. So, okay, those parts are good. What I would do is our request ID is equal to our owning tree, animation interface, and we do issue request data, and we need a callback. So I'm going to have an on animation completed like that, which means I have a function here, detected void on animation completed, and in terms of parameters, that gets firstly our identifier, so our int32 of the request ID, and then the in reason for why it's completed. So that's good. We issue the request. We're storing the data there. Our last status in this case then ends up being that we are in progress. Now, otherwise, it's actually very similar, except what we do down here, we don't bother storing the request ID. We don't link it up to the completion function because we're not waiting for it to be completed. And our last status ends up being that we succeeded. So this allows us to use this one behavior tree node for both the scenario of kicking off a long-running animation that we're waiting for, or for just pushing state to the animation system as well. So if we just wanted to push through a bunch of booleans, things like that, then we've got support easily for doing that. So it's really handy. So that's good. So, okay, so far so good. In the onAnimation completed function here, well, if our in request ID is equal to our current request ID, then we would say is complete is true, and our current request ID, we can reset that back to -1. I'll also do similar here of resetting that to -1, just so that we're leaving things in a very consistent state. So all we're doing here is setting that boolean. The other thing I will do here is we should fail out if the animation interface is null, or if the request data, if it fails that validity check. So if it's not valid, we shouldn't try and use it. So that's good. The tick logic, actually really straightforward. So if the last status is already that we failed, so if And actually, I would say if it's anything other than in progress, then what I would do is just use our set status and calculate return value with that. Because if it's succeeded, then we should just return succeeded. If it's failed, we should just return that. It's only if it's in progress could it actually be anything any different. So what I would say then is we return set status, calculate return value. If it's completed, then we return succeeded. Otherwise, we go for in progress. So nice and straightforward for the actual tick logic there. And final one is I should override our onExit. And what I want to look for is if we actually have a request in progress. So if our request ID, if that is greater than or equal to 0, and we still actually have a valid animation interface, just to be safe, shouldn't really change, but it's good to just have that extra caution there with it. Then what I would do is our animation interface, cancel request, and that request ID. And I'm just going to, with that request ID, set it to -1. So that's good. That's actually all that our node needs to do. It's quite simple in terms of its behavior, which is ideal. We don't want it to have to be super complex and super involved. It should be something that's quite straightforward. So a couple of things then I want to do for being able to test this is I want to actually modify our idle action. So this sits under our hybrid GOAP. So it's this that I want to actually modify. So what I'm going to do is I am going to give this serialize field, and we'll have an animation request, and we'll just call this animation data. Now the animations, I don't necessarily want it, especially if it's firing, I don't want it to just continually fire it again and again necessarily. So I want to have a cooldown before it can actually reissue it. So what I'm going to have here is animation cooldown time. And I want that to be, I think, at least 5 seconds, and it could go up to 10 seconds. But I want to have a bit of a cooldown that has to exist there, essentially. So this changes a little bit how I structure the behavior tree. So if we have animation data, so if that is not null, and if it is valid, then we're going to do slightly different logic. Otherwise, we'll use our same logic as before. So this just means on a per AI basis, we could have different animations, different sort of setups there. So how this will work for if we are running our animations is I want to actually use a parallel node. So what we would set up is our local root. Still do add child to root node, except this would be a flow node parallel as parallel. And then what I will do is the primary branch will be the weight, and then the idle will be alongside that. So we'd have local root, and we would do set primary. And this would be our new, actually this would be exactly this. No need to reinvent the wheel. would be exactly that. Now with our idle one, what I want to do then for the actual animation side is I want to be able to do something like this, where I say idle will perform animation. That I want to do local root set secondary, and because we have that cooldown, what this would be is a flow node sequence. And I would say that that is called perform animation as BT flow node sequence. But we'll notice we get an error here. And that's because our set secondary doesn't actually support using it in that way. So I'm going to modify these so that both the primary and the secondary can be used in this way. This just expands the capabilities of these out a bit and makes them overall just a little bit more useful. Because then that logic will work. And that means I can do a cleaner sort of setup for this, where for performing the animation, I add a child that ends up being a BT action send animation request. That's our animation data, like that. And we would say we do wait for completion. And then I just add in the cooldown afterwards. So we get a new BT wait, min animation cooldown, and a max animation cooldown. So now our idle supports a couple of extra ways of working, which is really handy. It means that it's a little bit more functionality, a little bit more usable in terms of what it can do. Those look good. So we should be able to set that up and test that out. So we'll have to modify our behaviors here a little bit to see this, because we don't normally see the idle animation, because these always have something to do. So what I'm going to do temporarily is I'm going to turn off all of the interactables. And then I'm going to go to the base prefab for our behavior tree AIs. And these do have our idle. So we've got the goal and we've got the action. So what I will say is, and we've got a few different ones that we could choose here. I think we will go for just actually kicking off the particular state. So I'll go for gesture. So that means every one of our behavior tree based AIs now support that. So with the interactables turned off, they should kind of have no choice but to perform their idle animation, because they should wander and they should go and then go into their idle. The thing we might run into, though, is wander is a higher priority than idle. So it might just be that they end up continually wandering. We'll see. So we can see wander has a priority of 10, and I don't believe wander has any cooldown on it. So that's okay. So what I can do temporarily is I can go to our idle goal, and I will modify it so its priority is actually the maximum. What I'll also end up doing is I'll add in that animation support to the wander, because that's kind of useful too. So we'll test that. These should now all perform the gesture. They'll go on to cooldown, and we can see that, and that one's cooldown's finished. So they'll finish at different times. So that's good. So we know that our behavior tree logic is working there. And what I can do then is we've already updated our idle action. Let's update our wander action because all of them have that. So we can update our BT action idle. That's good. We'll go for the wander. So the same things we added into idle, we're going to add those into the wander as well. So we'll bring those over like this. So we can just have that animation configured. And then we'll need to do a similar set of logic that we did with this. So I'm going to just bring over that part of it. It'll be structured a little differently for the wander, which is okay. Because what the wander currently does is it has this move, and then we go into the wait. So what I'm going to do instead is we'll have our else here. That. So, okay. We do want to have a flow node parallel here still. And this is our wander wait. So wander wait going to be a little different. Still got the same min wait times and everything. But we just now have, in terms of our setup, it's done under a parallel node. So it'll still actually do that waiting logic. It's just now we can configure an animation for it. And again, no extra logic needed to be added to it. So it's really easy to bundle in kicking off one of these animations into our setup, which is what we want in the end. Like that's the whole point with a lot of these generic interfaces and all, is to make it that there's a lot of code reuse and it's a lot of very simple logic. And because this is a contained class, I can copy it and I can just paste it in here. So it will do the same thing. So what I should find is that it will now wander. Now we can see that with the wander, it is not actually waiting for the flow to complete. So we just want to check what's actually happening there. And that is because this should have been a local root add child like that. So it wasn't actually properly set up. Let's try that again. And we should see that behavior kicking in now. So they wander, perform their gesture, they're doing their normal wait. So they can loop that animation if it's short enough and if the cooldown's short enough. But that's good. So now when they go and are wandering around and stop somewhere for a bit, we could have them perform an animation to look around or other things like that. So we've got our setup there now with behavior tree support. Our animations are nicely integrated. So we've got a really good base there for this. So the final thing that we want to do, and this is more of a quality of life thing for this and just sort of a little bit of extra functionality, is I had mentioned that with the animation side of things, at the moment we are just always undoing the parameters, but that's not necessarily a thing that we always want to do. So what I'm going to do is set up here a option on the particular parameters and some general logic so that we can decide whether we want to undo ones or not. So that will have parameter mode. We'll have use request default, always undo, always leave. So that looks good. We will put that into here, public, and this will be our undo mode, which by default, we just want to use the default, because what that will let us do is public bool undo on completion, and we'll have a public bool undo on exit or on interruption. Just because I could see that we might want to have two different configurations there. So just to make it that it's sort of covered. I don't think per parameter we should do that, or maybe we should. It's kind of, let's actually support it. Undo on cancellation, and we'll have an undo on interruption. Okay, so by default, those will work. This will default to true. This will default to true. So that should mean that what we can see is if we go to the particular AIs and where we can send those requests, then we'll see we have those options. Now that hasn't actually properly ticked that. That's interesting. Hasn't done it for Wander either. Let me just, as a test, add that onto something else. Just to see if it's going to actually properly populate it, because that actually should be populated by default. What I will add is, I will remove this afterwards. This is purely just for testing. Just want to see, okay, so it must be because those are already set up and it's new variables that have been added that it hasn't actually populated that correctly. So that does mean I want to make sure I go to behavior trees here and properly enable those. Should be okay for the individual parameters, not that we're using any of them. Make sure that that's ticked. So that's good. That should fix up all of our behavior tree ones. So we should see that that's correct when we look here. So those are correct. Our prefabs for the actual interactables are probably wrong as well, though. So I'm going to go to microwave, because these have configurations in them also. So I want to make sure these are correct too. Okay, those did update. Interesting. So the actions didn't update, but the other ones did. Very strange. Eat food, make hot drink. Those are both correctly updated. Those are right. Just check all of these. Just because when it works for one thing but not another automatically, there's not really, they're all prefabs. So it really isn't any different between them. Okay. No clear reason as to why that is the case, but we've at least fixed that up. So those are populated correctly. So, okay, we've got our different undo options there. What that means is we can then go and update our actual animated bridge for where it does the cleanup. And so what we would want to be checking is, okay, the reason there is going to determine which of the undo modes we actually use. So undo by default, that's going to be, well, if our reason is that we have finished, then we use current request undo on completion, otherwise current request undo on interruption. Now our set state here, and actually all of this, has to actually be put under here. What I would say is if for some reason it's doing a cleanup and we don't have a request, I will always set it to the idle state. But in this case, if we have a request, we'll use that logic with the idle state. What this then means is for things like our Boolean parameters, the logic here changes a little bit. So if we should undo is based upon what that setting is, but if parameter undo on cancellation, and this is, we need to get the parameters undo setting. So what we'll do is pull parameter default, and similar logic if the reason is that we finished, then we use parameter undo on cancellation, or we use parameter undo on interruption, but that's actually giving us not a Boolean, but instead our parameter undo mode. So from that undo mode, we can then say, okay, well, if undo mode is always leave, then we can skip. Otherwise, if the undo mode is always leave, sorry, if the undo mode is always undo, or we're using the parameter default and we're not undoing by default, then we push the Boolean. So if it's always leaving it, we just skip, we make no changes. If it's always undo, or if we should not be undoing by default, then we will go and undo it. So it's a little bit involved, but this should make it a little bit easier for this working with it. This logic is... The handy thing, though, at least, is we can use the exact same logic here for both. So that's just going to mean that our system has the option for being able to, do the resetting, do the pushing of those bools if we want it to, but we don't have to have it do that. But by default, it will. Now, what I'm also going to do, and I usually do this at the end of each one, is a code cleanup. That just gets rid of unnecessary usings. I've gotten in the habit of just periodically doing that. It tends to keep the code a lot cleaner, and because autocomplete has a tendency for just going and throwing in additional ones, it makes it a lot easier for working with. So let's again test, make sure everything is still happy, which it should be. So they can still play their animations. There's still an issue at times with the walking. It seems to only happen the first, like on their first walk. Afterwards, it's then fine. That's still a background thing I'm looking into. But they're playing their animations. So that's good. So, okay, we've got our setup now where we have a node for being able to perform animations. We've modified our wander and idle behaviors so that they can also include an animation. But if they don't, everything will still work as before. So we've got all of those bits up and running. We've made some improvements there with the animation so that we don't necessarily need to undo the parameters. The advantage with that is you might have something where you might want to do a sequence where, okay, the first part of the sequence, you might send an animation request and it's not waiting for completion. You're not undoing anything. You just push a bunch of state to the animation system. You might then do some other things. And then at the conclusion of that, you push some more state. So it just gives us a little bit more flexibility if we're not making it mandatory that the undo happens. So it just gives us a bit more options there. But dive on in and experiment with this, see if there's any other things you'd like to be adding to it, and see what kinds of things you can create with it. So folks, hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out, it's really appreciated. If you have any questions, chuck those in a comment below. Now, if you're looking for the code for the project, there are 3 links in the description. The first is to the code as it was at the beginning of the video. The second is a link to the code as it is now. And the third is a link to the completed package that you can import into Unity projects. So those are available. The code is free to use in any projects, commercial and non-commercial ones. And if you're looking for any other ways to support the channel, then I do have a Patreon, and there is a link to that in the description as well. But until next time, bye.